Welcome to Gary Clarke Tech and this latest tutorial, which is going to be all about PHPStan, which is a static analysis tool, and what it will do is it will analyze your code without actually running it, and it's looking for problems with the structure in your code, so problems in the structure which could potentially lead to bugs. So whereas tools like PHP Unit will find problems with behavior and find errors in your code, that way PHPStan will look at your code and find potential improvements in the structure. Much of this lesson and some of the code which I'll use in it is taken from the Testing PHP course, which is a full course about testing PHP in all kinds of different ways and covers things like test-driven development, testing strategies, feature tests, unit tests, integration tests, as well as code coverage and lots of other stuff. So if you're interested in that, it's over 100 lessons, and I'll leave links to that at the end of the video and also in the description below. Okay, time now to take PHPStan for a test drive. What I've done is I've created a very simple small project, and it's got just 5 files inside of there, inside of a source folder, and each file contains errors which PHPStan will pick up on, but it will pick up on errors at different levels that we run it at. So you can get this from GitHub. I'll leave a link to repo if you just want to clone this, or if you're on garyclarke.tech, I'll leave the files attached to the lesson. First thing we need to do is we need to get PHPStan. So the way that we're going to do that is we'll just say composer require. We're requiring it as a dev dependency because you don't need to run this on production. This is just for local development purposes. Let's run this. Okay, and so if you started with an empty project like I did myself, then we should see a composer JSON file has arrived. We've got composer lock, and then we have a vendor folder, and inside of there we've got PHPStan, but we'll also have some auto loading should we need it. Okay, let's go and actually run this, and what I'm going to do is I'm just going to run it at the very lowest level and see how we get on. The command that we need is this: vendor bin PHPStan analyze. Notice the way they've spelled analyze. That's something I picked up on. It's spelled with an S instead of a Z, so that's more like the English spelling of the word rather than the American English spelling of the word. And then you need the name of the folder. So later on I'm going to show you a way when we create a config where we won't need to actually specify the folder that we want to analyze, but here we're just going to analyze the source folder. We don't have a test folder at the moment. Let's just go and run this. Okay, so we are running on level 0 and everything has passed. So level 0 is the very lowest level, so it's telling us that everything in these files will pass at this very lowest check level. However, if we want to run this at a higher level, what we do is we say vendor bin PHPStan analyze, and then we can pass a level. We can do it by saying -- level followed by the level number, or we can do the shorthand, which is -l, and then it is the numbers 0 to 10, or it might be 0 to 9, but we're just going to run this at level 2, so this is just slightly higher than what we ran it at, and let's see what happens this time. Okay, so this time we have some errors. We've run it at a slightly higher level, and you'll see the output is very good. It'll tell you exactly where the problem is and what the problem is. So on line 6 of file 1, saying variable, undefined variable might not be defined, and then on line 16 of file 3.php, we are making a call to an undefined method, example class undefined method. Let's go and have a look at file 3, and that is what we're looking at here. So we have a class called example class. It only has one method called do something, but we're then making an instantiation of that class and we're calling a method which is undefined on that object. Okay, so we're all set up. We know that this is working. We've had a brief look at the different rule levels. Don't worry about that too much for now, because in the how it works section you'll learn a lot more about that, but you should be up to this stage, the same stage as me, and you should have PHPStan installed and working. Let's have a quick look at running commands. It's something you've already seen me do in the first or in the last recording that we just did. But here's how it works. Here's how they are formed. So it's vendor bin PHPStan analyze spelt with an S instead of a Z, and then any options, and we'll look at those in a second, and then the paths. And so for example, here we're just looking in our source folder, so that will be src. But if we also had a test folder, you just add them on like this. So if you had like another folder that you wanted to look on, you just keep adding them here. So we've only got a source folder. Let's have a look at options. We've already seen one, haven't we? Because we looked at rule level number 2, and it's 0 by default. So if you don't specify a rule level, it will run at the very lowest level, which is quite forgiving, and most things or a lot of things will pass, and then you just make it more stricter gradually. And so that's what we did in the last one, and we ran it at level 2. Let's just remind ourselves. Okay, and that found 2 errors. If we were to run it at a higher level, we would get more errors, but I'm not going to spoil the surprise on that just yet. Let's have a look at some more options and how you add them. So when we ran that, you'll see we get this little progress bar actually. If you don't want that, for example, if this is something which is going to be run in Docker or whatever, then you can run it with quiet mode, which is Q, so if you don't want any output. And then, like I say, you can run it without the progress bar. So I think it is this, no progress, and we'll run that. That ran okay. As you can see, no progress bar. And the other one I was just talking about was quiet mode, which is quite a common command which you might run from the command line for various things, and that will just not output anything, so you'll just get an exit code with that. And so that might be all you need to check for. And then another one which I've seen in the docs might be quite handy is memory limit. So you can set a memory limit, how much memory you want to actually dedicate to this task. And so obviously we're well within 1 gig of memory there. Let's now start to have a look at the rule levels in a bit more detail. So like I said previously, the default is level 0. That's fairly forgiving. A lot of things will pass at that level. And as you increase the rule level, then it gets a little bit more intense, a little bit more strict, and you'll start to see more failures. Having said that, even if you drop PHPStan into a legacy project at level 0, you're still very likely to see a lot of failures. And so then you can sort of think about what your strategy is going to be and at what rule level you're going to set things at. And you also have something called baselining, but I'm not going to spoil that for us. We'll have a look at that shortly. First off, let's just run this with some different rule levels and get a feel for how they work and what kind of strategy we can use on this very simple, unrealistic code base, but hopefully you should get the picture. So vendor bin will remove this memory limit from the previous command. So like I said, the default is 0, but we'll specify 0 anyway, and we know that everything is going to pass at that level. Let's increase it by just 1. Okay, and so we just get the 1 error at that. So that would be nice and easy, go in and just fix the 1 error. How about if we go and run it at level 9? Okay, so you might run it at level 9 and think, well, that's quite a lot of errors. Actually, it's only 5 errors here, but you can imagine on a different code base, you might get something like, I don't know, 200 errors, and you might think that, well, that's quite a lot to go and fix. So what you would do is just play around with it, you know, a bit of trial and error. What do you think is a reasonable amount? If you think you have capacity to fix maybe 20 fairly straightforward errors, then you know you're getting 20 errors at level, I don't know, say 4 or something like that, then it might be worth just going in and setting it to level 4 and fixing those errors, and you can just increase the strictness over time depending on what your capacity is. So that found 4 errors. I'm going to change it back to 2, and then we'll run this. So we know we have 2 errors at level 2. This would be a good place to actually just check out what they are and maybe go in and fix these, and then you'd have a passing test suite at level 2. So in file 1 we have an undefined variable, and in file 3 we are making a call to an undefined method. So let's go to file 1. We have an undefined variable here, so for example you might go and fix this. So you've done your fix, run your tests again. Okay, we've only got one error now, and that is in file 3. We're calling an undefined method, so we'll go and fix that. So I've now added a method to that called undefined method. Like I said, these are fairly unrealistic examples, but it's just to show you really how the tool works. When we go and use it on our real testing code base shortly, then this will look obviously a lot more realistic. But here it looks like we should have a passing test suite. So we know that we're passing at level 2. Let's try our luck at level 3. And we actually start finding more failures there. So we'll go back to level 2 and we'll decide that is what we are going to set our rule level at for now. I'm now going to show you one way of how you can ignore errors. So you might run your tests, see that you're getting a couple of errors on things or a few errors on things, but you might see an error and think, okay, I know about that one. I know that the code is functionally working, but PHPStan is just picking something up. Good old PHPStan. But you actually just want to ignore that from the output and ignore that from the results. And so in order to do that, what you can do, we'll just go and run the test first. So I'm running this at level 2. Sort of back to where we started. So the fixes that we did in the last video, I'm on a different branch and those errors are still in here. So we have these 2 errors at level 2, one in file 1, one in file 2. And so in file 1 we're getting this variable, undefined variable, might not be defined. So if you want to go and put a suppression inside the code, you can do this by just saying one of two things. You can put it above, and so here you can say PHPStan ignore next line, and so what that means obviously is it's going to ignore the next line. So PHPStan isn't even going to look at that or try and evaluate it. So if we go and run them now, we just have the one error, and that was for the one in file 3. Show you a different way of doing it. Instead of saying ignore next line, you can say ignore line. But to do that, you obviously have to put that on the very same line. So here we're going to say PHPStan ignore line. You need to make sure that you get this syntax right. In fact, I think you can use double slashes. We'll try that in a second. Let's go and run this. Vendor bin PHPStan analyze level 2. Okay, that's all passing, and you can actually just do it with comments like so as well, I believe. Let's do this. Yep, again, no errors. So that's one way of ignoring errors, just by putting these little suppressions inside the code, but that can soon start to become a bit of a mess. So what we're going to move on to in the next section is going to be all about configuration, and it'll show you how you can actually take into account certain errors inside the config. And we're also going to have a look at something called baselining, which is really cool, where you can sort of take a snapshot of your code in its particular state and say, okay, I know about all these errors, let's forget about all those for now and just deal with any new errors which spring from this point onwards. Let's now have a look at config. So configuration can be a bit of a dry subject sometimes, but with PHPStan you can actually do some really cool things with the config. So I think it's an important topic for us to cover. The way that we configure PHPStan is we use something called a PHPStan.neon file. So the .neon is a very similar format to YAML, as you'll now see. So let's go and create that file. In the very root of our project, just going to create a file, and we're going to call it phpstan.neon. Okay, and so I'm using PHP Storm. As you can see here, it's telling me that there are some plugins which support Neon files, but what I've been doing up till now, because Neon looks pretty much exactly like YAML, is I have a little thing where in PHP Storm I can just click on that, right click on that, and say override file type, and if I just say YAML, then it's still a phpstan.neon file, but it's making it, treating it like a YAML file just in PHP Storm. Okay, and so if we look at some of the commands that we ran, previously we specified a level and we specified paths. So we can actually configure those in our PHPStan.neon file, in our config file, and that means that we won't need to keep providing these. We'd only provide them if we wanted to override the config that we're about to create. So let's add those. We can add them under parameters. So if we create a key called parameters, then we'll create one called level, and we'll say we're going to run this at, let's just go with level 4, just chosen randomly. The changes which I made in the last video are not in this branch, so all those errors will be actually back here. And the next one is paths, if I remember rightly, and this will be an array of paths. We only have one called source. So let's now go and run this. We don't need to specify the level. We don't need to specify paths. We can just say vendor bin PHPStan analyze. Because we've named this file according to the conventions and because we've put it in the project root, then this file should now be read. Let's run this. Okay, so I think we saw something about reading config at the very top there. Yeah, so here, vendor bin PHPStan analyze, and then it said note using configuration file, and it said we are using this file. So if you ever have any ambiguity about where config is coming from, then that's a handy little thing to be able to just see and say, okay, that's where my config's coming from. And then we have 1, 2, 3, 4, 5 errors at level 4. 4 errors at level 4, should I say. So this is a very simple setup used for just my own local development with one config file. But what should you do if you're working in a team? What config should you use there, and what should be shared with other developers, and what should you keep for your own local use? We'll cover that in the next one. In the last one, we had a look at how we can create a basic config file which we can use for our own local development. But how about if you're working on a team, in which case you'd need a config file which can be distributed. And so for that reason, we can create a .dist file, and that will be the one which goes into version control. And then the one which we did in the last one, the PHPStan.neon, that can be our own local version which we can use to override some settings from the distributed version. Let's have a look at what I mean by all that. So we'll go and create that distribution file which I spoke about. So we'll create it in the exact same location, almost the same name. It will be phpstan.neon.dist. Okay, so this one will be version controlled. phpstan.neon will then go into our git ignore. So we might as well do that while we remember. So I'm just going to drop phpstan.neon into the git ignore, and then we'll go and add some parameters to our phpstan.neon.dist. So this is what I've done there. I've just kept it nice and simple for us to start off with. Same as we did in the last one, just got a level and then the paths. And then to demonstrate that we are just overriding this file, including the settings which we don't override, what I've done is we've stuck with level 4 in the phpstan.neon, but I haven't actually specified any paths. If I run this now, I'm expecting maybe to see an error because we're not actually telling our phpstan.neon about the dist file. So if I go and run this, at least one path must be specified to analyze. So let me tell you how this works. At the moment, because we have a phpstan.neon, that is taking precedence and that is being read over the phpstan.neon.dist. If I was to add options to the command, then those options in the command would overwrite what is in my phpstan.neon. So the hierarchy is command line, then phpstan.neon, and then phpstan.dist. So how do I get those settings which are in phpstan.dist? How do I actually use these without having to re-specify them in phpstan.neon? Well, the way you do that is you include the dist file in your phpstan.neon file. So you can have an includes key and then include any of the files, so you can include multiple ones. And so for that reason we use an array, but this will be phpstan.neon.dist, and then hopefully now if I run it, PHPStan will know to use that path which we have specified in the neon.dist file. Let's go and run this again. Okay, so this time that worked. It found the paths, and then if we go and read this bit at the top, it says using configuration file phpstan.neon. So it's reading that file, but it knows to get the settings which we haven't specified, or it knows how to get them because we are including the phpstan.neon.dist. If I didn't have a phpstan.neon, in fact, let's just delete this. What it would do is it would read the phpstan.dist file. So we'll scroll up to the top here. That one's set to level 2. And so this time it's saying using configuration file phpstan.neon.dist. Okay, so I'm just going to put that file back which we deleted, and then I'll show you a use case for something or things which you might want to put in your phpstan.neon file, or put in any file for that matter, but we're going to put it in the phpstan.neon. So just going to run this. We know that we're running this at level 4 and that the phpstan.neon.dist is at level 2. So if I go and run this analyze, okay, so I know that this failure here is happening at level 4, but it's passing at level 2, and in the same way as what we ignored errors in the actual files a couple of videos ago, you can actually put ignore errors in your config file. So let's go and ignore one of those errors in here just to demonstrate this. So this is what I've dropped in there. The error that we got, function sum numbers should return int but returns an array. If you want to ignore errors in a config file, you can use this ignore errors key within the parameters key or underneath the parameters key, and then you set your delimiters. I'm using hashes here, and then the message. Notice I've also had to escape these parentheses here, otherwise I'd get an error with this. But if I go and run this now, we should see 3 errors instead of 4 because we are ignoring one of them. Okay, found 3 errors, and as you can see, the one regarding sum numbers has now gone. And so that example is okay. For something like that, maybe you won't want to ignore it, but say for example you're using a different setup, you have like a different distribution of what is being used in the pipelines, you might have different versions of PHP or certain extensions which aren't installed, which sometimes happens, and you're getting an error regarding that. Then in your own local config file, you can just say, okay, I know about this, this is just my local development, it is different than what is actually working in the production or in the pipeline, so I'm just going to ignore this, and that then for that the ignore errors is perfect, or is perfect for your local config file. We're now going to have a look at a way in which we can take all the currently known errors and use them to generate a baseline, so that when we run PHPStan again, it won't actually tell us about those errors that we already know about. It will only report new errors which have been added since we generated that baseline, which is pretty cool. So let's go and give this a go. The way I'm going to do it, or the baseline I'm going to use, is I'm going to use the dist file to generate this baseline, because this is what is going into version control, and then I can share that baseline with the other developers as well. So I'm not going to base it on my current local development phpstan.neon file. I'm going to base it on the phpstan neon.dist file, and the command looks like this. So let's go through this piece by piece. Vendor bin phpstan analyze, so that's just the same as for any PHPStan command. Level 2, we know about setting levels, and then we're pointing it, or we're saying use this configuration. So the phpstan.neon.dist file, the folder or the path will be source, and then the important bit, or the bit which separates this from commands which you've run in the past, is this here, generate baseline. And what this will do is we'll go and take all the known errors which are reported from actually running this, and it will just add them to the baseline file. Let's give it a go. Okay, so it's telling us that it's generated a baseline with 2 errors. Let's go and have a look at that. So the file, or the new file which you should see, is this phpstan-baseline.neon. And so inside of there, in fact, let's just go and override file type as YAML, so it's a little bit easier to read. And this is what it looks like. Parameters. So it's nothing that we haven't actually seen before, because I previously showed you how you can add a ignore errors parameter. And what the baseline does is it just creates this file and adds this parameters to that, or it adds this ignore errors key to the parameters. And then what we need to do is actually then go and include this in the file. So this will be included in our phpstan.neon.dist. But before we do that, let me just show you what happens if we go and run this. So I'm not generating a baseline here. All I'm doing is running that same command and running an analysis at level 2. In fact, I don't even think I need the level 2 there, because my dist file is set to level 2 anyway. Let's just confirm that. So I'm just doing a normal analysis, running the test here at level 2 of my phpstan.neon.dist file, and you'll see that it actually reports those 2 errors. So what we need to do is at the top of our .dist file is create an includes. This is where we can include other files, and the file we are including is phpstan-baseline.neon. And then when I go and run this, that will be read. It will see that we have some parameters with ignore errors in there, and it will simply ignore those errors in the same way as what it ignored the errors when we manually added it to our other config file. So vendor bin phpstan analyze config is phpstan.neon.dist. Let's run this. Okay, no errors. It will only report the errors which we add from this point onwards, or from the point in which that baseline was generated onwards. So let's try this out and make sure that anything new or any new errors do get reported to us. So we'll just put another undefined variable in file 1, and hopefully we should see a new error, but only an error for the new ones which we have put in there. Okay, so we've got only one error found, and it's saying variable another undefined variable might not be defined. So in that file we can see that we clearly have 2 errors, and they're both the exact same error. However, one of them has been included in the baseline. We already know about it. We don't need to keep reporting on it. But the other one is brand new, and so this is one which we shall go in and fix. And that's how you generate a baseline. Hopefully you've seen the usefulness of that. Imagine you're working on an existing code base, you add PHPStan to it for the first time, run an analysis at whatever level, and you're probably going to get an explosion of errors. And so for something like that, a baseline could be perfect. You could say, okay, these are errors which you already know about. From now on, we're going to have good habits. We're going to set our rule level to X, and we're just going to focus on these ones which are generated from now onwards. And then if you have time and you have the capability, you could go back and fix some of the errors retrospectively which were generated before the baseline was added. Alright, now that we've got a pretty good grasp of PHPStan, let's take this for a little practical spin. We'll use an existing code base. I'm going to use the one from the testing strategies section of the testing PHP course, and what we'll do is we'll install PHPStan on that and run it for the first time, see all the errors we get, and then I'll have a walk through some of the things we can do, some certain extensions we can install to take care of certain things for particular frameworks, and also we'll finish off by generating a baseline. So this is the repo. It's inside of Gary Clarke testing strategies on GitHub. Just going to grab this link here, git clone. Alright, so I've opened this up in PHP Storm. Let's just run the installation for PHPStan. So composer, require, we only want this as a dev requirement, PHPStan. And then we should see that our composer JSON has been updated in the dev requirements, and also there'll be changes to the composer lock. Okay, but let's actually go and run this. So first off, I've not worked on this for a while, so first what I'm going to do, I'm going to run PHP unit and make sure all those are still passing. So we're still getting passing tests for that. And then let's just say that we're going to try and aim for level 6, with this repository. So vendor bin PHPStan analyze. I'm analyzing at level 6 on the source folder and the test folder, and let's see how we get on. Okay, so we've found 22 errors. Quick scroll through these. You'll notice that I'm seeing some which are related to doctrine, so we're going to come on to that shortly. This is quite a regular error which you might see. No value type specified in an iterable type array. So I think what we'll do is we'll look at a way of fixing that at some point in the future. Alright, so I've made a mental note of a couple of things there, a particular error which I think is quite common, and also stuff related to doctrine. So what we're going to do is we're going to focus on those two things first, and so in the next one we're going to have a look at extensions which you can use for particular frameworks and libraries. Something pretty cool about PHPStan is that you can install extensions which have been written for particular frameworks and libraries, and they include custom rules which are written to take account for the way that certain pieces of code are written in those frameworks and libraries. And so what we're going to do here is we're going to install one for doctrine. I know I'm using it in this project, and so it'll be pretty cool to have that included, and I'll show you how we can do that. The first thing we're going to do is we're going to include, or we're going to install the PHPStan extension installer. If you come over to the documentation, there's a little section on the extension library, and it tells you how you can go about installing extensions. So the first thing we're going to require here is this one, PHPStan extension installer. And again, we're going to require this as a dev requirement. So let's go back to back to the terminal. I'm just going to paste that in there, composer required dev PHPStan extension installer. It's saying, do I trust PHPStan extension installer to execute code, blah, blah, blah. We're just going to say yes to that. Okay, our next concern is getting the extension for doctrine. So this is pretty good. As you can see here, we have all these framework extensions. The top ones are official, so these are ones which have been worked on with PHPStan, and then we have these unofficial ones. So you may have heard of LaraStan. That's an unofficial extension of PHPStan, which is built particularly for Laravel. But the one we want here is doctrine, so let's go and have a look at this. Hopefully it should give us a line where it'll show us how we can install it. This is what we're looking for. Composer required dev PHPStan doctrine. So if it's got PHPStan as the package vendor, then you know it's an official extension. All right, let's go and run this. Composer required dev PHPStan doctrine. Okay, and then when I go and run these tests, if you remember we had 22 failures at the end of the last one. Let's see what happens if we go and run this again at level 6 now. So previously where we had 22 errors, we're now down to 12 errors. So why are we down to 12 errors now? It's because we've installed that PHPStan doctrine extension, and it knows about things which are particular to the doctrine library. And so custom rules or custom analysis has been written to take that into account. And so it's well worth checking if you're using a particular library or framework to see if there's a PHPStan extension for that, and it might do a lot of the hard work for you. In this one, we're going to have a quick look at fixing errors and some places where you can look to get some help on fixing them. So when you run the tests, you'll get your list of errors here. But a good thing about it is you'll see sometimes this line here which says C, and it's basically pointing you in the direction of where you can actually find a solution for that error. So for example, this one here, property app command update follows command account IDs type has no value type specified in iterable type array. So if you've run PHPStan for the first time on an existing code base, you're very likely to see quite a few of these. So quite a common one. Let's go and see how we can fix it. So I'm just going to click on this link, and that takes me to the PHPStan documentation. And so basically we have an array here, but we're not specifying what types are within that array. At the moment, there's only really one way to do that, and that is in the doc blogs. above the code where the problem lies. And so that's how we're going to fix ours, and our fix is very similar to this one really. So we have an array of account IDs. I know that those account IDs should be integers, so what I'm going to do is where the offending code is, I'm just going to put a doc block there, and I'm going to say, okay, the array should contain integers. So back over to the code, we're looking for the update follows command. And I believe it was complaining about the constructor. And actually looking at this constructor, we know that we can now use promoted properties rather than having all this junk. Here we're declaring the properties and then we're injecting them and then we are setting them. We can clear a lot of this stuff out. So probably good that PHPStan has pointed this out because it's shown us where we can just improve some code in general, I think. So I'm just going to take each of these one by one. In fact, first I'll comment these out. And then, so account IDs, I shall cut that from there. I will replace that, change that to a comma. All of these properties can be read-only, so if they can all be read-only, we might as well make the class read-only. Okay, but that has been a code change, so before I do any PHPStan stuff, what I'm going to do is I'm just going to run the PHP unit tests to make sure that I've not broken anything there. So vendor bin PHP unit. Okay, we're still getting all of our passing tests. Now let's go and fix the PHPStan problem. So I'm just going to add a doc block here. Okay, and so what we're saying is that the account IDs will be an array containing integers. So I'll say array int. Now if I go and run PHPStan again now, vendor bin PHPStan analyze source tests. Okay, so I now have 10 errors. So that little move there has actually cleared out 2 errors, which is pretty cool. So I think what we'll do in the next one is we'll actually go and generate our config, because at the moment we're just including all our commands from the command line. So we'll add some config which says that we want to run this at level 6 and that these are our paths. And then once we've done that, we shall generate a baseline from that config, and it's something which I might let you have a go at. As promised, I'm now going to let you have a go at configuring PHPStan and setting a baseline for this repo which we've just been working on. So I'll walk through the steps one by one, but it's nothing which I haven't already covered, so you should be fine with this. So step 1, create a phpstan.neon.dist file. So yeah, instead of creating like the phpstan.neon, which is one which you could use locally, want to create one which can be distributed here. So we need a phpstan.neon.dist, and then we want to set the parameters for level 6 and the paths. The 2 places where our code is in this repository is obviously in the tests folder and in the source folder, so configure it for those paths. And then using that config, what I need you to do is generate a level 6 baseline from that config file at phpstan.neon.dist. And then if you remember what we said when we've generated that baseline, it won't work automatically. What you need to do is actually include the baseline file in your config file, and then once you've done that, run PHPStan again to check and make sure that the baseline is working. Alright, so let's give this a go. First thing I need to do is create a phpstan.neon.dist file. So I'm just going to copy that text there, go into the very root of the project and create a new file, phpstan.neon.dist. I do want to add it to source control, and then I'm just going to do what I've done previously, where I override the file type. One thing I will say about this, don't know if I've mentioned it before, is that when you do override the file type in PHPStorm, when you next come to open it, it hasn't sort of remembered that. So it might be wise to use the plugin and test that out if it's something that you're going to be doing a lot. Okay, how do we configure this? The first thing we need is parameters, and then level. We said we're going to set level 6, then paths, and this will be an array of our paths. So that will be source src and also tests. Okay, and then once that is generated like that, I should be able to run it without specifying the paths and the level. So vendor bin phpstan analyze tells you which configuration file you're using, and there it's told us that it has found 10 errors. So it knew exactly where to look, it knew exactly what level we're running this at, and so all is good so far. What we want to do now is go and generate that baseline. So what I've done is I've just added this to the configsteps.txt file just so I can have a look at it and check it out beforehand. That all looks good to me, so then I can now go and paste this into the terminal. And so we're saying vendor bin PHPStan analyze at level 6. The config is phpstan.neon.dist. The paths are source and tests, so I want you to go and do this analysis and then generate a baseline from it. And the way you do that is you just tag on this. So hyphen generate baseline. Let's hit go. Okay, so it's telling me that a baseline has been generated with 10 errors. Let's go and look for this. We have a phpstan baseline-baseline.neon. Copy the file name from that, and then in order to use that, if you remember what we did, we had an includes where we can include any other files. So you can include phpstan.neon files within phpstan.neon files. Obviously, they'll need like different names. So for example, you could include phpstan.neon.dist inside a phpstan.neon file. Paste that in there. So we're including our phpstan-baseline, and that means that I should now just be able to go and run this. Vendor bin PHPStan analyze. Okay, and so now it's telling me we're using this file as a configuration file, phpstan.neon.dist, but it's also telling me that we have no errors. So it will only report any errors which are new. So let's actually, just for thoroughness, go and throw an error in here. Let's actually go and test out something which we added recently. So here we added this line to say that this array of account IDs will be an array of integers. Let's actually change this to string and see how good this is. Will it correct this, or will it find any errors? Let's go and run this. Vendor bin PHPStan analyze. Okay, so now it has found 2 new errors. Source command, update follows command, parameter 1, account ID of method, app repository, Twitter account repository, last record expects int, string given. And the one that we explicitly just broke there, parameter number 3, account IDs of class app, command update follows command constructor, expects array string, but an array of integers was given. Okay, perfect. So we know that's working really well. Just going to revert that back to a passing test. Let's go and run this. We now have PHPStan set with a baseline at level 6. There are some known errors, but it's not reporting those to us anymore. It will only report any new errors to us. As a small bonus to finish off this tutorial, I'll share with you a useful little continuous integration workflow, which means that whenever we try and merge anything into the main branch of this repo, then the tests are automatically run for us. For this, we're going to use GitHub Actions. It's really simple to set up. Most people have GitHub, and it's just a case of creating a particular file in a particular location in our repo, and this is it. So inside of our project here, we create a folder called .github. Needs to be named like that. That's a specific naming convention. Inside of there, we have a folder called workflows. And then inside of there, you just need to create a YAML file. Doesn't really matter what you call it, but it does need to be a YAML file. I've called it PHP-CI, and that pretty much explains what this is for. It's for continuous integration of our PHP code. Okay, and so there are a few keys in this file. I'll go with them and explain them as I scroll through this. So first off, we just name this, and then this key here on, we're basically saying, well, when do you want this to actually run? And so the options we've gone for is when we try and push to the main branch, or when we try and create a pull request into the main branch. And then you specify the jobs that you want to run. And so we've just got the one, and that is build. Runs on specifies the type of machine to run the job on, so here we're saying Ubuntu latest. Steps, and this defines the steps that will be executed in the job. So actions /checkout v2 checks out your repository. This Shivan Mather setup PHP v2 sets up a PHP environment. So you'll see that on PHP GitHub action files, it's quite commonly used. And then next we're going to install dependencies. So first we run composer install to install PHP dependencies, and then we're going to run our test. And so the order that I've done the tests in, and this is my recommended order, is to run your static analysis test first. So we're going to run PHPStan, and then we are going to run our PHP unit tests. Okay, so I've kept this file fairly simple and just kept it to the very bare dependencies, the very bare bones of what we need here. We don't need anything too complex in order to achieve our outcome here, and that is to run PHPStan and to run PHP unit whenever we try and merge into that main branch. Okay, so over on GitHub, I have pushed my code. I'm going to go and create a pull request, click new pull request, and I'm going to try and merge my PHPStan branch into the main branch. And so if you remember what those conditions were, we said when we try and create a pull request into the main branch, then this should trigger this build. Okay, so let's go and create this pull request. And then once I've done that, I'm just going to call it add PHPStan, create the pull request. Okay, and then what we're going to do is we're going to go over to GitHub Actions, and this is what has been kicked off. Okay, I've got a green tick, so that is telling me that all has gone well. Let's go and inspect this. Click on build. So remember, that is what we named this. And these are those steps. So the main ones that we were looking for, we wanted to make sure that we have a passing test suite. So we'll check our PHPStan. As you can see, okay, no errors, everything has passed there. Let's check PHP unit. And there we have 12 tests, 20 assertions, no failures. So when we merged into that main branch, or when we created the pull request in order to merge into that main branch, this kicked off this build, it ran our test for us, and we know that everything is good. If you've enjoyed that and you'd like to learn more about testing PHP code in all kinds of different ways, then check out the full Testing PHP course from which a lot of this material was taken. I'll leave a link to it at the end of the video and also in the description below. And don't forget, I also offer a discount for my subscribers.